Okay, thank you, Hang. Then we move to Pawas, right?
Yeah, you guys can hear me? Hello.
Yeah.
Yeah, yeah.
So I'll start with basically with the whole refactoring cycle of a Jupyter notebook. So before that, I'll show you one of my Jupyter notebooks. It's simply a data analysis, exploratory data analysis. And you can see I have simply used it on my drive. It's not reproducible. There are various comments and lots of tables and graphs. And so whenever someone may try to, like I have exported it on my GitHub profile as a project, as a repository, but even then I have not provided any README. Uh, so for all this, in the whole video series, we have been learning about uh, refactoring code and reproducible code. So when it reaches the production level, we can actually use it. The end user can actually use it and experiment it. So so this is just a summary of the whole presentation, as in we'll first see that the notebook is well and running. Like there are no specific errors to the notebook itself. We'll make a copy of it. We'll convert it to Python file and do the refactoring because whatever Hang explained is kind of similar to the start of my presentation. Then there is unit testing, characterization testing, and then deployment, adding functional rests, and seeing how the model works after deployment. And then again, if any input has to be provided, if the build is wrong, we can uh, deploy it from another previous build. So these are all the things that I'll be explaining. So first of all, I've just added a GitHub link to that Python notebook. So you guys can access it and see there are so many, as I just showed you, there's so many comments and explanations and text, and it is, and it grows for so long, like a notebook can be so long that in order to just, okay. So in one notebook, I have simply done the data analysis, and then second, I had to again import the data, a final data that got prepared through that that Colab notebook, and then again use the decision tree classifier, and in another notebook, I did logistic regression. So this is kind of what David Tan explained to refactor and use IDE and use Python file in order to uh, have your code reach to production level, and so the end user can use it. Uh, so, so, so I made a copy of the exploratory analysis in order to see what works or what doesn't work for my data. And then and this is what Hang explained, identifying code smells and then removing them in order to make the code better. Uh, uh, so you could see that simply all the exploratory analysis that I did, which was not required as to the final output. So we can simply remove it from our final Python file. Yeah,
I think your screen is freeze right now. Not sure if I'm only. Your screen is freeze right now.
Okay, so
Okay.
should I like rejoin? Is it still freeze?
It in PowerPoint right now. Okay. It's okay. Okay, you can continue. Sorry.
Is it okay now?
Yeah, it's okay now.
Hello. Yeah. So, a list of code smells that Hang explained were removing unnecessary comments and instead work through clean, explainable function names that describe what actually code is doing, removing dead codes which do not add to the output. So I converted my notebook to Python file, and I've also done it in PyCharm. I mostly done it in PyCharm. So you can see this is the copy of, and you can see when converted to Python file, there are so many errors in my ID. My ID identifies so many errors. There's no Seaborn module. There's so many comments, and you can the problems could be listed here, and they're like you can see like 2 errors, 10 warnings, 79-week warnings. So that is like the benefit of using IDE. It actually eases your burden of refactoring the code. So so I did the import, removed all this, and whatever was left was simply this much of code. And this is not like very good clean code, but the imports are what I exactly needed into the code. And the docstring can be explained better. There could be comments where you could maybe the end user can see why we are dropping that particular row, why we are dropping that particular column. So why we are doing removing, changing things, whatever, and why we are using this model, and what does it exactly do. So I have not written any major doc file for this, but uh, this is like in the middle of refactoring. So you could see earlier I had this whole taking in CSV, then looking into the first 10 rows of the CSV data frame, then finding if there is null value, and creating plots, saving plots, and you could see this for loop that I use. This could, if even if we need it, like in my current project, in our later in the project, it could be converted to function, which could simply intake some arguments and do this instead of simply using for loop in the whole Python file. And we don't need to import much of the image displaying modules. So so this is basically what Hang explained. So I've done kind of similar thing, and I've created one test functional file for this is actually characterization test. So in my actual file, I have used decision tree classifier to classify churn customers and non-churn customers. In test function instead, I can actually use the model DT. So I'll simply run it now to see if the test passes that the characterization test that I have set the scores must be greater than 0.5. So instead of decision tree classifier, I'm using logistic regression here. It's still running. But the gist is simply to see that the characterization test is working. The test is working. Whatever function you are testing, you have to import that. And okay, it's still running. It's kind of slow. It says the test passed. It didn't print. Okay. So there may be some error because it didn't print the assertion message. So I'll look into that later. So this is what I wanted to explain with the refactoring, and most of it is what Han explained already. So yeah, so determining boundary or seams of refactoring and add characterization. Sorry. So basically, I yeah. So in my notebook, you could have seen that the data loading, the pre-processing and preparing, and everything was happening at so many different levels and so many mixed levels. So I'm really sorry. Yeah, so that sums the characterization test that I just did for train data function. So the so the refactoring process was just the same, and I'll move on to the last lecture that David Tan delivered in Microsoft Office somewhere around 2019. And he actually explains uh, what clean code looks like and what refactoring does, and how code can be from our basic local level Jupyter Notebook can be converted to production level, and what are the best practices, how actually animal workflow result in the final production level end user uh, tasks. So, so the journey of an ML project. So it could be explained through this that, and we all can agree that when we do ML, machine learning in any of our tasks, uh, the data training and data the model training on data and the testing is requires a lot of pre and post configurations for in order to reach to the production level. So the first you could see the configurations. So as Hang explained, we need to configure our environment, and Docker is kind of one configuration management tool which allows us to not let our personal hardware or OS affect the use of the portability of code, which could actually be much better. Then there is data collection, which is quite a lengthy process. And there are various open source platforms where we can use their data, but in order to actually use it for our personal projects, where this is one of a kind project, where uh, since the data science is booming right now, we need lots and lots of different kinds of data. So, and then we need to perform feature extraction, data verification is needed. So before actually going to the ML level. So all this was before actually applying machine learning, the data analysis, the preparation, the extraction, all this. And even after we have a trained model, we need to actually check the uh, uh, if the model is compatible with whatever the deploying tool we are using. Then there are servers which needs to be monitored and so on. So uh, so David Tan actually has listed some readings. He works in ThoughtWorks, and there's an excellent reading which I'll go through at the end of the presentation. And he has reference to GitHub repositories, which I'll also visit at the end of the presentation, because these are like excellent code refactoring and reusability tips and actual uh, working help any ML beginner to actually go from beginner to actual production level coder. So the first problem is what I explained is works on my machine is to use a configuration management tool, and Docker is one of those. We saw that Anaconda is kind of that, but Anaconda is heavy built, and Docker is is not that heavy built. And then there's the problem of data, or that at the start of any project we don't have much data. So, for example, before the car part project that that Thang is leading, so we saw that at first the car we simply did the car part detection and classification of different parts of the cars. Then we needed damage detection. Then we needed special windshield data for different windshield part detection, the camera zone, the driver zone. So in order to categorize a business problem, we have different domains, and we need as we further go into that business problem, we need much more data for different domains inside the business problem. So, so this is kind of so at first we simply use the car data to identify different parts of the car, and then we moved on to detect the damage of the different damage on different parts of the car. Then we moved on to windshield. So, this is how actually it is suggested to work on any ML related business problem. And while we go through deeper and deeper into the business problem, we learn how to collect data better. We learn how to use the data better. Yeah. So, and after the model is trained, we have to deploy it. And deployment, as in the first few lectures, we learned about continuous integration pipeline, where after first few it is suggested to deploy early and often. When we make Git commits, we usually do early, often commits in order to if we So in future, if we make any mistake or our model is not working, we can actually go back to the last commit. So it is often suggested to make commits frequent and often. So this is what deploy lean often is. So you have a local environment set up, source code repository, and through CI we run unit tests. And if something is an issue, we go back with the feedback and we repeat the same process. And once all the tests is passing on the data, we train and evaluate the model. And if is there any error, we again go back to the local environment, we redo the process. And after we have a satisfactory model, different satisfactory models, so we have it staged, and whatever model we choose according to the metrics, we deploy the model to production. So usually choosing model to deploy to production, there are various metrics used. So here you could see an example of R2 score and RMSE. So there are different metrics used in order to see the different performance of different models. So you could see that R2 score of this third model is 0.88, and RMSE should be less. So it is 2.82. So this one is used, can be used. Okay, so after deployment, we can't just sit back because it's a continuous delivering process in the even after production. We have to manage. We have to see that the model is not outdated. The data set that we train the model on needs to be further uh, uh, fed more, and the new data has come up, which is a bit different from our training data, but our model needs to perform the same way. So we need to retrain again. So in order to do that, we have to observe, we have to monitor the model performance at the after the production. So this is like using the suppose an office has deployed a model for the end user and it wants to track it. So it is tracking the service usage, like how many requests to use the model has been received. Then what are the model outputs, like is it not going out of its line? Like the model output can be completely inaccurate, because what if the new user is using to retrain the model in a completely different data, the completely new data. So it can be it cannot, so it needs to be checked. And if it is, then you have to again you see the difference and check the model inputs. Then there is okay. So the benefit of that is okay. Okay. Closing the date. So that was like the benefits of seeing how the model is performing and the production level. So we can actually log in the performance of our model and use that if we need to retrain, we can use the better data, like now the mod logs in as in using the ground truth table as which data it has correctly identified, classified, and which data it has not. So the data tracking is simply a human analyzing the data and then again, using the data to feed into the model and evaluate. And this whole thing is kind of a continuous process. So that's why even after model is deployed at production level, the end user is using it, you have to, and if the performance drops, you have to like do it all over again. But this time you can simply go back and just adjust this with the data. So it won't be like doing it from the beginning. So this is like use of metrics. And so this is the summary. So there is one more thing, one last thing regarding problems of problems if we deploy it at the production level is, what if our model predicts some bias like racial bias or the kind of bias. So these are actual headlines that are from the major newspapers regarding the model biases. So in order to trace the bias, in order to remove it, we need to actually look into the data, because if data is not biased, we are not getting a biased model. If we have traversed the path pipeline correctly. But in order to identify that if the data is biased, we actually have to reorganize the data to make it ethical. And so this in order to do that, there's a data ethics checklist that is recommended. So I'll into that. Okay. So this is a data science ethics checklist about data collection, data storage, analysis, modeling, and deployment that is recommended. So whenever we are collecting data, if it's available open source, we can simply use it, reuse it, do anything with it. But if we want it from some organization, from some government, or someone personally, we need to have their consent, approval in order to use the data. And we have to identify the sources of bias, because in face recognition, we often have seen in the past the racial biasness of the models from blacks and whites. And it is, yeah, so these kind of also in order to, if we have retrieved someone's data and we are training it in order to predict it on new data, so we have to make sure that we maintain the privacy of that data. And in future, if that particular organization or person needs their data to be removed, we need to make sure that we do that. Or we can simply automate a time period where we can, suppose after a year or a month after the training of the model, your data will be deleted. This kind of schedule or plan can be made. Or in order to analyze the data, and we can use like different tools and graphs and modules, but the representations should be honest. And just as I explained, the biasness of the facial detection, we have to keep in mind of that. And there's modeling. So we have to check that the different hyperparameters, we are not like the model is not like totally dependent on one hyperparameter and is producing very good results because of that. And we need a better metric selection in order for our model to uh, be properly accurate, result in better accuracy. or to determine the metrics of it. All apart from all those, there are the different business requirements. So in order for the deployment, we need to actually keep different builds of the model. So if our model in future stages do not perform good, we can simply deploy previous build and use it to use it at the production level. So, and we have to make sure that we prevent the unintended uses and abuse the model. So everything has to be planned if we have to take our project from the initial Jupyter Notebook to the final production level. Okay, so this is it, and this is like the summing up. So that's all. Thank you. Anybody would like to discuss something?